Hey everyone, welcome back to Learning Lane, the channel where curiosity meets clarity. Today we're diving into a fascinating mystery of nature, rivers that flow backward. Yes, you heard that right. Rivers that don't flow the way we expect. So, how can a river actually flow in reverse? Let's find out. Section 1: The usual flow of rivers. Before we talk about backward rivers, let's quickly recap how rivers normally work. Water flows from higher elevation to lower elevation, pulled by gravity, usually from mountains to oceans or seas. The direction of flow is determined by the slope of the land, also known as the gradient. So, under normal circumstances, rivers never just decide to flow the other way. Something has to change, and that's where the story gets interesting. Section 2: When rivers flow backward. There are actually a few situations that can cause a river to flow in reverse. Let's explore the main ones. 1. Earthquakes or geological uplift. Sometimes powerful earthquakes can shift the Earth's crust so drastically that the land tilts in a new direction. When this happens, the gradient changes and the river's flow can reverse temporarily or even permanently. For example, in 1812, the New Madrid earthquake in the central United States caused parts of the Mississippi River to briefly flow backward for several hours. Imagine seeing one of the world's largest rivers suddenly reverse. That's nature's raw power in action. 2. Strong winds and storm surges. During hurricanes or intense storms, strong winds and massive waves can push water upstream, especially near the mouth of a river. For example, during Hurricane Katrina, the Mississippi River's surface flow reversed due to the intense storm surge pushing ocean water inland. The river didn't change course permanently, but for a short time it did flow backward. 3. Tectonic or human-induced changes. Human engineering can also flip the flow of rivers. When we build canals, dams, or diversion systems, we can change a river's natural direction. Example: the Chicago River in the United States originally flowed into Lake Michigan, polluting the lake. In 1900, engineers reversed the river's flow using a massive canal system, making it flow away from the lake instead. It is one of the most famous examples of a man-made backward river, when for glacial or seasonal causes. In colder regions, melting glaciers and ice jams can cause temporary backward flow. When ice blocks the river's path, meltwater can get trapped and overflow backward until the blockage clears. Section 3: Modern examples of backward flow. Let's look at a few notable rivers known for reversing direction naturally or by human design. Chicago River, USA, human-engineered reversal in 1900. Mississippi River, USA, reversed temporarily during the 1812 earthquake and major hurricanes. Amazon River, South America. Millions of years ago, it flowed east to west toward the Pacific. But after the Andes Mountains rose, the terrain shifted. Now it flows west to east into the Atlantic, a complete geological reversal over millions of years. Tonle Sap River, Cambodia, naturally reverses direction every year. During the rainy season, water from the Mekong River pushes back into Tonle Sap Lake, expanding it dramatically. In the dry season, it flows out again, a truly unique, living example of nature's rhythm. Section 4: Why this matters. Backward flowing rivers show us how dynamic our planet really is. Earth's surface is constantly shifting through plate tectonics, climate change, and even human intervention. These reversals remind us that rivers aren't static. They evolve just like the landscapes around them. So the next time you see a river, remember what looks calm and predictable today might one day flow the other way. Nature always has a surprise up its sleeve. If you enjoyed exploring this with us, don't forget to like, share, and subscribe to Learning Lane for more amazing discoveries every week. Until next time, keep learning and keep flowing forward.